The teaching of Vedantu was amazing. One aspect where Vedantu teaching differed from a normal offline coaching was the attention teachers gave to our doubts. No matter how many times we asked a doubt, the teachers would patiently clear the doubt every single time. And they made learning a very fantastic experience for us.
Hi guys, this is Saurav here and welcome to another awesome session of Chemical Kinetics, and this is lecture 4 of the series. And in this session we will be talking about first order reaction. If you remember, until now we have done rate law, order, molecularity, and we have discussed zero order reactions. Okay, so hello Gautam, hello Ajay, hello Prateek, hello Gabbar. So this is in this lecture, and this is the first lecture of first order reaction. Why this is the first lecture of first order reaction is because first order reaction के ऊपर एक लंबा discussion होना चाहिए. First order reaction is very vital. First order reaction के ऊपर बहुत सारे cases बनते हैं. If you take gaseous reactions, if you take reactions taking place in aqueous mediums, so there are so many sub cases which are possible where you have to calculate rate constants and all. So it is vital that you get all of them in order, and that is the reason ये first lecture बोला गया है. इसके बाद और भी 2-3 lectures होंगे जो कि सिर्फ first order reaction पे ही होंगे. Okay, so let's start today's session. And if I look at if we look at the things that we have completed until now, we have completed rate of reaction, rate law, order and molecularity, zero, first, nth. जब तक ये खत्म नहीं होता तब तक ये blue नहीं होगा. So this will remain red until everything over here is done. So it will take some time. Okay, so bear with me, it will take some time, and just remember to practice as many questions as possible. It's possible to score 120. 120 is very challenging. However, 100 and above is easy. Okay, it's easy to score 100 and above in chemistry in JEE Mains. Okay, yeah, you can ask a question. Okay, hello Vishisht Amarwal. Okay, so you can ask a question. So let's start today's session, and let's start today's session with what the homework question that I had given you. So I'd given you, hello Ritesh, I'm fine. I'd given you this homework question. This was the problem question which was given, and this question was for this reaction A changes to 3B, and this reaction takes place which is of, this is a zero order reaction. This is a zero order reaction. For this zero order reaction, we can see that this is for reactant, that is A, and this is for B. So we can see that the rate, the concentration of reactant is decreasing and the concentration of B is increasing. Also, there is a point where the two curves or two straight lines meet with each other, and this time is at 20 seconds. The question that was given was that what will be the half-life of this reaction? What will be the half-life of this reaction? Sir, can I get a good rank in JEE Mains because I started preparation? A lot of people start preparation just 6 months before JEE Mains. So don't worry about it. Just be persistent, just believe in yourself, and बाकी जो होगा आगे देखा जाएगा. Okay? अपने ऊपर भरोसा रखो. So let's try to solve this question. A lot of people had, so Shiv is saying that 20 will be the answer. Ajay says that 20 will be the answer. Let's see. So what is happening at this point? Can anybody tell me what is happening at this point? At this point, the concentration, so at this point, can I say that the concentration of A and B are equal? At this point, it's not equilibrium. Please don't say that it is equilibrium. Please never say that it is equilibrium. You do not know what is equilibrium. The point of equilibrium is when the rate does not change. You can see that the concentration is changing. Equilibrium का जो situation होता है वो तब होता है when the concentration becomes constant. The change in concentration becomes constant. Okay, so this is not equilibrium because you can see that the concentration is changing. So it is not a state of equilibrium. Equilibrium ऐसा होगा. If it is equilibrium, it will be like this. At this point, you can see that the concentration stops changing. In this region, it stops changing. So it is not equilibrium. Please don't ever say that it is equilibrium. This is the point where concentration becomes the same. Okay. So if concentration becomes same, what can I do is this. What can I do is this. So just a moment. Let's say the initial concentration is A. Let's say the initial concentration is A and this is 0. After some time, this will become A minus X and this will become 3X. Isn't it? Initial is A. After some time, it will become A minus X and this will become 3X. So at 20 seconds, since the concentration of A is equal to the concentration of B, can I say A minus X is equal to 3X? Can I say A minus X is equal to 3X? Just try to understand this, that at 20 seconds, the concentration of A and concentration of B, which is A minus X and what is 3X, will become equal. Okay? When this becomes equal, can I say that A becomes equal to 4X or X is equal to A upon 4? X is equal to A upon 4. Okay? X becomes equal to A upon 4. When X becomes equal to A upon 4, let's do this. Okay? When X becomes equal to A upon 4, let's do this. We know that X is equal to K times T. Okay? X is equal to K times T. We can calculate K, which is equal to X, which I have written that A by 4. What is the time? Time is 20 seconds. Can I say that? Okay. Can I say that if I incorporate the value of X का value क्या है? A by 4. And ये किस time पे हो रहा है? 20 seconds पे. If I place this over here, I will get the result as A upon 80. I will get the result as A upon 80. Now what is half-life? Half-life is A upon 2 times K. Half-life is A upon 2 times K, which is equal to A by 2 times K. K value is A upon 80. So this will become 40. Aapka A will get cancelled. This will become 40 seconds. The right answer will be 40 seconds. Okay? So, did you understand the method? See, the major problem people face is differentiating between equilibrium and when the concentrations become equal. Okay? Equilibrium is a stage where concentrations becomes constant. Okay? And this is the point when two lines cross with each other, the concentration lines cross with each other, the concentration curves cross with each other. That is the point when concentrations become equal. That does not mean that equilibrium has arrived. Okay? So remember that in zero order reaction, it is fairly impossible to achieve equilibrium. It will always go like this. Zero order goes towards completion, so it will never achieve equilibrium. Okay? It will never ever achieve equilibrium. एक zero order reaction तो complete होता है ना? It gets completed at a certain time. I know the time when it gets completed. The time at which it gets completed. What is the time at which zero order reaction will get completed? It will be equal to when X will become A upon K. So I know the time when a zero order reaction gets completed. So this curve will always go down and meet the time axis जहां पर की concentration 0 हो जाए. Okay? Equilibrium is a scenario. If you want to understand equilibrium, then equilibrium is a scenario जो कि इस तरह से achieve होगा. Your concentration will decrease and after a point it will become constant, and your concentration of products will increase, and after some time it will become constant. So this is concentration versus time. So can you see this point? At this time you are observing that the concentration is not changing. ये constant हो जा रहा है ना. अब देखिए ये concentration is becoming constant with respect to time. So since it is becoming constant with respect to time, इस point को हम बोलेंगे equilibrium. This point becomes equilibrium. Okay, this point becomes equilibrium. Ayush, please look over here. I've just explained this. Concentration of reactant will decrease, concentration of product will increase, and एक time पे जाके दोनों का concentration constant हो जाएगा. It will become constant as well. अगर ये constant हो जाता है, if this becomes constant, then what happens is that equilibrium state has arrived. Equilibrium state has arrived. Ayush, I have answered your doubt. Please look over here. आपके doubts answer हो गए हैं. Okay, इसको बोलते हैं equilibrium. This is known as equilibrium. This point is not equilibrium. Can this point be equilibrium? No, not equilibrium. This is not equilibrium. Equilibrium is a scenario when concentration becomes constant. यहाँ पे क्या concentration constant है? No, because concentration change कर रहा है. You can see that the concentration is changing. Concentration is changing. But over here, concentration becomes constant. Okay? ठीक है? So in a zero order reaction, will we ever achieve equilibrium? No, because zero order always reaches completion like this. Zero order will always reach completion. We will never see a scenario where concentration runs parallel to the time axis. Okay? Concentration runs parallel to the time axis. We would never ever see this scenario. Okay? So with that idea in mind, let's move ahead. Let's take this example, okay? Let's take this example. Using the integrated form of rate law, determine the rate constant K for a zero order reaction if the initial concentration of the substance is 1.5 molar and after 120 seconds, the concentration of the substance is 0.75 molar. Okay, so what is the rate constant? You have been given the value of reactant. So एक reactant है which is converting into products. It is converting into products and it is being told that initial concentration is 1.5, final concentration is 0.75, and the time in which this happens, is 120 seconds. So what would be the rate constant? Rate constant क्या बोलेंगे? Rate constant is nothing but x upon t. What is x? What is x? X is whatever is the change. X क्या होता है? Whatever is the change. This is half-life. Yeah, obviously this is half-life. So what is x is whatever is the change. So change is 0.75 upon 120 seconds. The answer for this will turn out to be, इसका आंसर कितना आएगा बताइए? 0.75 divided by 120 will be your answer. Initial concentration minus final concentration gives you the amount which is consumed divided by whatever time it takes for that consumption. That will be the value of rate constant. Okay? Is that clear? So let's look at the solution. 0.75 upon 120, that comes as to be 0.0062 moles per molarity per second. Okay, 1 upon 1, so it turns out to be 0.00062. अब देख लीजिए वही किया गया है. Okay, rate constant is 0.0062 molarity per second. Clear? Let's move ahead. Let's take the next question. Using the substance from the previous problem, what is the half-life of the substance if the initial concentration is 1.2 molar? What is the half-life of the substance if the initial concentration is 1.2 molar? So K value is 0.0062 molarity per second. And what is half-life for a zero order reaction? What is half life for a zero order reaction? बताइए, हाँ बताइए, प्लीज सॉल्व कीजिए. आयुष, ट्राई टू सॉल्व दिस. Okay, please solve this question. Very good, Ajay. The expression for calculating half-life is A upon 2K. You think 60? You think 60? Let's see. A value is given as 1.2. This is 2 times 0.0062. This will be half-life of the reaction. Are you getting 60? Just take out you can use a non-programmable calculator. So this will be 12.5, 10, और ये हो जाएगा Are you getting 60? A value is 1.2. So what will be the value of what will be the value of half-life? So this is gonna be the value of half-life. If you calculate this will be giving you the value of half-life. Okay, let's look at the answer. Answer should be 96. How did they calculate this? How did they get 0.6? They've gotten 0.6 by putting 1.2 upon 2 times 0.0062. It's not 193, there is a mistake. Half-life depends on the initial concentration. The initial concentration in this question is taken as 1.2. So if it is taken as 1.2, so what will be the outcome? आप A की जगह 1.2 रखोगे, एक्सप्रेशन ये होता है A upon 2K. तो K की वैल्यू तो आपको मालूम है, you know the value of K, you put the value of A, you'll get the answer. Okay, Shailendra, 96. Okay, it is 96. Okay, it's 96, not 100. Small error है, but ठीक है, कोई दिक्कत नहीं. Fine. So let's move ahead and let's talk about what are the examples of zero order reaction. There are few examples of zero order reaction that we can remember. The first one is decomposition of hydrogen iodide in presence of gold catalyst, decomposition of ammonia. It is decomposition of ammonia to form nitrogen and hydrogen, decomposition of N2O. Okay, nitrous oxide to form N2 and O2, combination of hydrogen and chlorine to form HCl in presence of sunlight. So this is the most common example. I will get to that, Jaideep. I will get to that. That's a very good question. I'll get to that. The answer is no, but I'll explain that why it is no. Okay. So these are some examples of zero order reaction. आपको examples याद करने की ज़रूरत नहीं होती है, but yeah, for boards and all, you might have to write an example if they are asking you to explain zero order reaction. So you might have to put some examples. So one example is hydrogen chlorine combination, one example ammonia decomposition. ये आपको easily याद हो सकता है. Okay. So let's look at first order reaction. Let's look at first order reaction. And what we'll do is we'll derive first order expression for the first order reaction, the rate expression for the rate constant first order reaction. We'll try to derive this. And how do we do this? We'll do it in the same manner as we did for zero order reaction. So what I will do is I will take a reactant which is converting into products. A reactant which is converting into products, and initial concentration is A, this is 0, it becomes A minus X, this becomes X. Okay? This is at time T, this is time T, this is time 0. Time 0 represents initial concentration and time T means concentration after certain time. Okay? So I can write dx upon dt, which is the rate at which product is being formed or rate of reaction, is equal to k a minus x to the power 1. Because this is a first order reaction, the rate of reaction will be dependent on how much of reactant is present at a certain time. Okay, what is D? Yeah, differential, instantaneous, we are calculating instantaneous rate. Okay, okay, वो करते हो ना आप differential. Okay, so what we would do is we would integrate this. We would integrate this. Okay, we'll integrate this, and dx upon a minus x, which will be equal to k dt. What is the integral of dx upon a minus x? It will be minus ln a minus x, which will be equal to k t plus c. आपको एक इक्वेशन ये आ जाता है. You get one such equation. Okay, you get one such equation. Very good, Himanshu. Minus ln of a minus x, you'll get one such equation. Now for calculating the value of c, what you would do for c, what can I do? At t equals to 0, x is equal to 0. When t is equal to 0 and x is equal, अरे पहले theory तो समझ लो, be motivated. Okay, first order reaction is not straight forward. पहले theory समझ लीजिए, problems आप कभी भी कर लोगे. First understand the concept. So when t is equal to 0, x is equal to 0, then so t is 0, x is 0, so c becomes equal to minus of ln a. Okay, minus of ln a. Clear? So how do we finally write the equation? We finally write it like this: kt is equal to ln a minus ln a minus x, which will be equal to k ln a minus x will be written as ln a upon a minus x, 1 by t ln a upon a minus x, or we can simplify this to 2.303 upon t log a upon a minus x. This is your equation that you would be using. आपने ये equation use करना है. Okay? Himanshu, yeah. See, I am not. Ln means natural log. Yep. Okay. So this is the equation that you would be using. 2.303 by t log of a by a minus x. Okay. Log to the base e. Yes, Jaideep. Yes. Yeah, Shailendra, please ask your doubt. Doubt पूछ लीजिए. Now, yeah, आपने पूछा कि definite integral क्यों नहीं use कर सकते हैं? Because I'm not good at maths. Okay, so I use indefinite integral because I am comfortable with that. I'm not a maths teacher, so मुझे chemistry में उतना ही maths आता है जितनी कि मुझे use करनी है. ठीक है? So it gets the work done. So I'm happy with that. So this is the equation that you would be using. This is equation 1. That is very, very vital. First equation. So can we not replace concentration by A by V? Yeah, concentration means number of moles by volume. This A that you are seeing over here, Shailendra, very good question. That A that you are seeing over here is nothing but number of moles by volume. Assuming that the volume is equal to 1 liters, N becomes equal to A. Okay, clear? So why don't first order reach reaction? अरे रुको तो अचिंत, पहले ये equation समझ लो. ये equation समझ में आ गया? Have you understood this equation? So I am just gonna write only this equation over here. My equation will be like this: K is equal to 2.303 upon T log of A upon A minus X. Clear? Now, can I say A was the initial concentration? Can I say A was the initial concentration? So A becomes initial concentration, let's say that is C naught. A is the initial concentration, that is C naught. Obviously Himanshu, so there is no point in including volume because number of volume cancel ho jayega. So A can be written as equal to C naught and A minus X can be written as equal to C. ये लिख सकते हैं. A can be written as equal to C naught and A minus X can be written as equal to C. So this equation will become K is equal to 1 upon T ln C naught by C. ये बन जाएगा. Okay, and if I further simplify this, I can write it as ln C naught by C is equal to KT, which is equal to C upon C naught, ln C upon C naught equals to minus KT. This whole thing can be further simplified to A is in, अरे A moles है, ये concentration A by V को concentration करके लिख लिया. Okay, so I can write C is equal to C naught e to the power minus KT. Can I write this? ये आपका second equation मिल जाता है आपको. Okay, now where do we use this equation? For generic calculations. अगर मतलब कि आपको examination में calculations करने को दिया गया, okay, if I do calculations for in the examination, I will use this equation. If it is this equation will generally be used when I would have to work on decay of particles. Like nuclear chemistry अभी तो है नहीं portion में, but when you talk about radioactivity, then radioactivity में this becomes initial number of atoms which are decaying, and this becomes the number of atoms after certain time n, certain time t, and this is written as lambda t. Okay, that becomes rate constant. Okay, C equals to C naught e to the power minus KT. It's a very easy equation. C by C naught is equal to minus KT. अगर आपको ln हटाना होगा, if you have to remove ln, so C by C naught will become e to the power minus KT. Okay, C by C naught will become e to the power minus KT, and that is how you have written this equation. Okay, is that understood? That is how you write the equation. This equation for radioactivity will change into this, where n represents number of atoms and n naught represents initial number of atoms. However, you can use any of these equations. but ये वाला यूज करो क्योंकि exponential functions को work करना examination में it will become difficult. Okay, it will become slightly difficult to work on this क्योंकि e to the power minus kt यहाँ पे कुछ भी वैल्यू लिख दिया गया, इसको कैलकुलेट करना थोड़ा मुश्किल हो जाएगा. Okay, so work with this. ठीक है, work with this. Clear? Now let's look at certain inferences. ये inferences काफी important है, and these inferences help us answer a lot of questions. Lambda represents the activity constant. Okay, for a radioactive substance, for example, you take U-235 and it starts decaying. So for it will be written as lambda. वहाँ पे k नहीं लिखते हैं. Okay, so these inferences are like utilized as direct questions in examination. Okay, these inferences are utilized as direct questions in examination. Clear? So what is the time of completion? So I will use this expression to explain that. C equal to C naught e to the power minus kt. What will happen at completion? Can I say at completion at completion, what will happen? The concentration, this final concentration will become equal to, the initial concentration. So, or I can say that C will become equal to 0. Let me write this over here. A changes to products, initial is C naught, after some time it is C, and at completion this will become 0. C will become equal to 0. C naught is not equal to 0. C should be equal to 0. C should be equal to 0. C naught will be not equal to 0. This is initial, this is at time t, and this is final. Okay, ITF represents initial at some time t, and this is final. If C is equal to 0, if you put C is equal to 0 in this equation, तो अगर आपने इसको 0 कर दिया, C naught e to the power minus kt, okay, this will become, this has to be equal to 0. Initial concentration is, why C naught? अरे C naught will always be some value. ऐसा तो नहीं है ना कि आपने start किया 0 amount of substance से. When you start a reaction, you will always start with some amount of substance. It will start decaying, decrease करता जाएगा, and you will finally get 0. Okay, so initial can never be equal to 0. So this is the total, the product of these two things is equal to 0. This cannot be equal to 0. So this has to be equal to 0 for this product to be equal to 0. Exponential functions can never be 0, sir. It can be 0. It can be 0 only when t is infinity. E to the power infinity will be 0. ये 0 हो जाएगा. Okay. Okay. Are you getting my point? My point is, when you are performing a reaction, let's say your initial amount was 10 moles. Okay, but that's not practical. That is the reason. That's not practical. See, what is practical and what is theoretical are two different things. I have to calculate the time of completion. It means that the time of completion would be infinite. The reaction will go on for infinitely long period. Okay, the reaction will go on for infinitely longer period. So any first order reaction is never ever complete. Okay. Okay, so try and understand, if this thing has to, let's say I start with 10 moles of a substance. If 10 moles of a substance is taken, it will reduce to 5 at half-life. It will reduce to 2.5 at half-life. 2.5 will reduce to 1.25 at half-life. So on and so forth. It will never ever, can half of something be equal to 0? So the time of completion of reaction for a first order reaction is never complete. First order reaction will never be complete. Okay. Yeah, I'm sorry, 1 by infinity, I'm very sorry, this will be 1 upon e to the power infinity will be 0. I'm sorry. Okay, e to the power infinity will be a value, but 1 by e to the power infinity, 1 by e to the power minus infinity आ जाएगा ना यहाँ पे. So at infinite time, at t equals to infinity, e to the power minus will get something like minus infinity value. 1 by e to the power infinity will be equal to 0. Okay, 1 by e to the power infinity will be equal to 0 because this will be an infinitely large value. 1 by e to the power infinity will be equal to 0. Okay, ठीक है, I'm very sorry. Okay, so ठीक है, so first order reaction will never be complete. इसीलिए if I try to draw this, concentration versus time. If I try to draw concentration versus time, what will happen? It will never ever touch the x-axis. It will go along the x-axis, which is the time axis, for infinitely long period. Okay, it will be an exponential decay plot. It will be exponential plot. So exponentially it will be decreasing, and it will never ever touch the time axis. Okay, it will never ever touch the time axis. It will touch the time axis only at infinity. So if you are ever being asked that will a first order reaction ever be complete, no, the first order reaction will never ever be complete. Okay, chaliye, let's talk about half-life. Let's talk about half-life. So what is T half? T half is the time when the initial amount reduces to half of its original value. So I can write 2.303 upon T log of A by A minus X. A minus X will become equal to A upon 2. Can I say that? Okay. Yeah, it is not gonna be completed after a very long time. Yes, it's not gonna be completed. इसीलिए ना your जो यूरेनियम अर्थ के फॉर्मेशन के टाइम में बना होगा, whatever uranium might had been present at the formation of earth is still present in earth. Okay, so whatever uranium you are seeing in earth has decayed for millions and millions of years. Okay, because decay, radioactive decay, is a first order process. So that sample of uranium was not created out of void. That sample of uranium is the one which is existing right from the time earth is existing. Okay, so it is going on. So it is a reduced amount of uranium. जब अर्थ का birth हुआ होगा, so when earth would had been born, at that point of time whatever amount of uranium was present, that is still persisting. First order reaction do attain equilibrium? Yes, first order reactions do attain equilibrium. So this is gonna be the expression for T half. I will write this as 2.303 log of 2 upon K, and this will become 0.693 upon K. Okay, one thing that you have to keep in mind that T half is 0.693 upon K. Okay, after more time it will reduce more. No, it will not be reduced more. The reduction will take place very, very slowly. Okay, the reduction will take place very, very slowly. So we can write this inference over here that T 50% or T half-life is 0.693 upon K. Okay, does it not depend on concentration? No, it does not depend on concentration. That is very important. You take uranium, 1 kg of uranium, and you take 50 grams of uranium. The time that it will take for 1 kg, let's say you take 1 kg of uranium, 1 kg of uranium, and you take 50 grams of uranium. 1 kg will take the same time to become 500 grams, which 50 will take to become 25 grams. Okay, half-life for a first order reaction is independent of concentration. Okay, half-life of a first order reaction will be independent of concentration. Clear? T half is the same as T 50%. Yep, T half is the same as T 50%. Now other instance, I have written other instance. So this is a small task for you if you have a calculator. So I want to calculate T 75%. I want to calculate T 75%. What is T 75%? T 50% is when X is equal to A by 2. What is T 75%? X will be equal to 3A by 4. Can I say this? X will be equal to 3A by 4. So the amount of reactant left is A by 4. 1/4 of the reactant will be left out. So I will put A by 4 over here. And what is the answer that I'll get? ln 4 by k. Very good. ln 4 by k is nothing but 2 log 2.303 log 2 2 times 2.303 log 2. Yes. So this will become how much? 2 times of this value. 2 times of this value. So essentially 2 times. So can I write this as 2 times T half? Because in examination they will ask you that calculate T 75%. Okay. So I will get it as 2 times of T half. 2 T half. Clear? Next, T 87.5%. What is T 87.5% equal to? When it is 87.5%, I will write X as, okay, if I write in terms of fraction, X will be 0.5A, X is 0.75A, X is 0.875A. Okay, 3 times of T half. I will get this 3 times of T half. T 87.5% is 3 times of T half. Okay. So can you see that the time is increasing but the amount is not decreasing? Let's calculate it for T 95%. Please tell me what will be T 95. T 95% is X is 0.95 of A. X is 0.95 of A. Okay, so T 95% will be, are you getting 4 times? 4 times T half. Four times T half. अरे how? X को 0.95A रखो. 95% का मतलब 95% has been consumed. So X is 0.95A. If it is 87.5, that means 0.875 of A is consumed. Okay. T of 99%. What is T of 99% in relation to T half? What is T of 99% in relation to T half? When it is 99%, X will be equal to X will be equal to 0.99A. 0.99A. Okay. Yeah, new technology, you can ask your doubts. So 0.99A, what will be this answer equal to? Is it coming as 5 times? Are you getting 5 times? Because it will be, kitna ho jayega? 100. I'm writing it as 5 times of T half. Approximately, okay. What is T 99.9%? What is T 99.9%? Mr. Rak, please review the video. आप फिर से एक बार देखोगे आपको समझ में आ जाएगा. It's not totally correct. It's 10. 99.9% is 6 times. Are you sure? 99.9%. 99.9% will be 3 times this value. So it will be 0.3 and 3. That will be 10 times T half. So previous वाले केस में क्या हो रहा था कि if it is T half, I will write it as 2.303 times log 2 by K, and T 99% will be written as 2 times 2.303 log 10 upon K. So this will get cancelled out. ये हट गया, so log 2 will be 0.3010 divided by, so it will be like this. Okay, so you are gonna get these values in examination. ये values आपको examination में आएंगे. You would be getting questions on T 50%, T 75%, 87.5, 95, 99 and 99.9. So you can see that as the time for the completion, I require more time for consumption. Okay, I require more time for consumption. Is that clear? More time for consumption. Is this clear? Let's move ahead. Let's look at the plot for the first order reaction. If I look at the plot for A at time t is nothing but A minus x, A naught is nothing but A. So if I plot ln of A naught versus, if I plot ln of AT at time t, how to calculate t? 99.9%, then 99.99% will be nothing but 0.01. Okay, 0.01 times of A is whatever is left, is 99 is left out, 0.01 is left out. So ये आपको ये calculate करना होगा. So if you use this equation, you will get this plot. If you use this equation, you will get this plot. You can alternatively use a simpler one. So एक simpler equation आप ये use कर सकते हो कि KT upon 2.303 is equal to log of A minus log of A minus x. Okay, log of A minus log of A minus x. So log of A minus x is equal to minus K upon 2.303 times T plus log A. So if you plot log of A minus x upon with respect to T, you will get a straight line with negative slope, and the slope of this line will be equal to minus K upon 2.303. Okay, this intercept will be equal to log A. Okay, this intercept will be equal to log A. Clear? Plots clear hai? What will be the plot for T half versus A? If I try to draw a plot of T half versus A, sorry, so if I try to draw a plot of T half versus A for a for a first order reaction, okay, for a first order reaction, what will be the plot? The plot will be like this. Constant jayega. Okay, it will be a constant with respect to the concentration axis because it does not depend on the initial concentration. T half is a constant for a given reaction. Clear? Now let's take a sub case. If let's say the initial concentration is not known, but the amount of reactant left at two time instants T1 and T2 during the reaction is known. You would get such subcases to calculate the x or to represent the expression for rate constant. How do you do this question? Or how do you get this inference? Initial concentration is unknown. So A is unknown. But what is known is A minus x1 at T1 is known and A minus x2 at T2 is known. Okay? A minus x1 at T1 is known and A minus x2 at T2 is known. Okay? So this we get these two things, we get these two values A remains unknown, I will use two equations. K is equal to 2.303 upon T1 log of A by A minus x1, and K 2.303 upon T2 log of A by A minus x2. From these two equations, I can calculate the value of K. Okay, if you divide these two equations, you will get the value of, अगर आप इनको divide कर दोगे तो K cancel हो जाएगा. Okay, if you divide them, they'll get cancelled. So you take it as KT1, KT2, and then subtract them. Okay, KT2, so you subtract. T2 is obviously greater. T2 is obviously greater. अरे यार, दो इक्वेशन को सॉल्व करना है. Okay, how do you do this? So K T2 minus T1 will be equal to 2.303 log of T2 minus T1. So this will come A minus x1 upon A minus x2. You will get this equation. A minus x1 by A minus x2. Clear? So this is how we would solve this. So I'll end the class over here today. Okay, I'll end the class over here today. We will take more inferences in the next session. Okay, so there are some 8-9 inferences that we get from first order equation where A is unknown, or time is unknown, or x can be represented as fraction, or if the reactants are gaseous. So in that scenario, how should we calculate the expression for rate constant, and what are the different assumptions that we have to take? What are the different mathematical manipulations we have to do? Okay, so let's stick to this. Let's solve some more questions in the next session. Please do join us in the next session. We'll continue from here. That will be the second lecture for chemical kinetics, that is first order reaction. Okay, so this is Saurav Goswami taking leave, and I hope you have a lovely day ahead. Bye bye guys.